Ah, c'est la fin du câble.
C'est mieux?
Ça marche,
ça? Ça marche plus?
Ça marche. C'est par période.
C'est un peu du câble. Non, c'est pas bon. C'est bon. Bizarre. Essaye d'adapter. C'est bien.
Okay, no problem. So I think everyone is back and we can begin again with the genetic algorithm. Okay. So just to tell you about the, we begin with the algorithms and its types, and then heuristics and its types, and now we come about the heuristic, which is genetic algorithm, a kind of heuristic I can say. So anyone who know about the genetic algorithm before, or you know, okay. Anyone else at the back side, especially? You know about the genetic algorithm? Genetic algorithm. Have you read it before? Okay. So basically, how the GA works, we call it in short a GA. Okay. So select first. What we do, we will select a two pair of the dashboard. Okay. But before I will say selecting a two pair of dashboard, how dashboard will get generated. Okay. So you can suppose we are generating a dashboard, as I already told you, everyone know how to generate one visualization. Okay, we have generated over there. Okay. Now when we are generating more than one visualization, we call it the dashboard. Okay, it is clear. Now dashboard is an individual. Okay. When we have a lot of dashboard, okay, which is generated using a random generation. Random generation is simply an algorithm of generating any dashboard. Okay. In my case, I am generating a dashboard. In other case, you can generate anything. Okay. We call it an individual. Okay, like human being. So first, what will happen? We will generate, in our case, 50 dashboard. Okay, as a random generation. It is randomly generating. First, they are selecting the visualization from a list. Like I have given a 15 visualization list, and then after generating a visualization, they are making a dashboard which contains around maximum 9 visualization and minimum 2. Okay. Just suppose we have 50 dashboard over here. Okay. The first step of the GA is selection. Okay. How we are making a selection out of the 50 dashboard. So let's see over here. Out of the 50 dashboard generated by the random generation, I am selecting the two pairs. Okay. And these two pairs are A and B and C and D. So what I do from 1 to 50, okay, I have a 50 dashboard, okay. What I will select any two pairs, means 4 dashboards, okay, randomly, like A and B, C and D. From these 50, okay. Just suppose there is A and B go here, A, B like 1, 2, 3, and C, D come here. In A and B and C and D, I will select one of them, any one of them, okay, randomly. Again, just suppose I select here, you can say A, and here I select D. Again, I select here the randomly. Now, out of them, I can do what I can say, 2 visualization will be done. Okay. Sorry, I forgot one point. I do have the binary tournament. Okay. So instead of selecting them, what I can say, randomly, I will do the binary tournament. Okay. Do you know what is binary tournament? No. Binary tournament is simply I am making a comparison between just we have 2 people here. Now, who is better? Out of 2 of you. Okay. I have to make some parameters. And that parameter known as the fitness function. Okay, FV, fitness value. Okay, I have to find which one of them is good and which one is bad. Same here. So I will tell you what is the fitness value later in the slide, but you can consider there is a function. On the basis of that, I am identifying the quality of dashboard. Okay. On the basis of the quality of dashboard, I have a fitness value. Which one have the higher fitness value? I have taken as A and as a D. Okay, it can be C or it can be B. Once I have a 2 dashboard over here, I will make them a crossover. Okay, how crossover will work? We will see one by one. Like when if you read the genetics, like we have a chromosomes like this, and one chromosome come on the other, and we got the crossover. Okay, the same genetic algorithm which was taken when the child was generated, in the same way this algorithm work. 2 chromosomes got crossover, and we got a 2 offspring in this case. Okay, but in real life we have only 1. Okay, so we have a crossover is done. We have now we have a 2 offspring. I will next slide we will see. Out of these 2 offspring, we can choose any one. So let's say 1. Okay, we got a 1 offspring. On offspring 1, we are doing a mutation. Mutation means the slightly changes on that particular dashboard. In our case, or in general, I can say the slightly changes you are doing in an individual. Just suppose there is an individual, I will change his face with someone else. You see, this is known as the mutation. If I change his hands, this other person hand. Okay, so I have do the mutation in 3 types in this dashboard. Okay, we will see. After doing a mutation, I will evaluate the dashboard. Again, I will make an evaluation on the basis of the FV, fitness value. Okay, if the mutated dashboard fitness value is greater than the fitness value, which one is the best over here? Let's say the dashboard number 29 have the best value. Okay, I will compare this after offspring. I will say mutation and I will say it M1. Okay, mutation 1. I will compare it with the 29. Okay, here. If this dashboard fitness value, okay, is good in comparison to this 29, I will remove it from here. It will go out and it will get replaced by the M1. Okay, this is working whole. The process is working like this. So you see the system. I have 50 dashboard. The worst one go out after GA. The best one replaced. The worst one go out and next one replaced. This is whole GA is working. So any doubts little bit in this? Now we will see it in detail. Okay. So before going about the GA, how it works, I will see genetic representation of the dashboard. In a dashboard, the first line you can see the visualization name. What kind of visualization over here? Like scatter plot, you can see this is the scatter plot. When I show you the student data set, you can see gender, but which IT visited resources, okay, on the X. You see the which ratios on the X. On the Y, you will see announcement view. Okay. Here is the announcement view on the Y. On the offset, which is the color, you can see the parents' school satisfaction. Parents, wait, I think I've taken the other dashboard. Yes, which scatter plot. I think there should be, this one should be class here. Okay, yeah, we can see, sorry, the class is here, I was seeing here, sorry. So the class, you see the color on the class, which is the offset, okay? So this is, we are generating. This is how the dashboard is looking for me at the back end. What, when the person, like novices will see, he will see only this, but for me, it's this line. Then again, for you can see the bar chart. So you have to find here the bar chart nominal, and you can start because we have the 1, 2, 3 bar chart. Okay, so you have to see which bar chart. We have the offset star ID. So bar chart is the star, this one. Okay, bar chart ordinal, offset is the color here. You can see star ID here, and then reagent on the x-axis. You can see the reagent on the x-axis, and y-axis you will see. Wait, again I've taken the wrong one. Reagent this one. Sorry, this one don't have the y-axis. Sorry, y-axis, there is no need of the y-axis because it is the frequency. Okay, so we have the stability and the x-axis, and y-axis is the frequency. So you see how it is generating. So the difference for the how I have generated at the back end, now how the novice is able to see it, or the common people. In a dashboard, there are operators and operations. Okay, like dashboard is like a individual or chromosome. I already explained. In terms when you see the in biological, we call it the chromosome. In the common life, we call it the individual. In my case, I call it the dashboard. Okay. Visualization are the big genes, the mutation when we are changing. Data attribute are the small genes, and visual attribute are also small genes. An operation like selection, mutation, crossover, and replacement that I have performed here. Okay. Now, selection crossover, I will try to explain how I did in terms of the dashboard. Okay. Parent A. I hope you remember from here how the parent A came. Okay. Just to remind you, the parent A came from here, and B came from here. So now we are doing the selection and crossover. So parent A is this dashboard. Our dashboard contains only 2 visualization, A and B. Okay, parent 1. Parent B contains a dashboard with 1, 2, 3, 4, 5 visualizations. Now we are doing here setting point. When I told you the crossover, we are taking some genes of dashboard 1. Like you can see in a biological, we are taking some genes of the mother and some genes of the father. In the same way, it will be here. Parent A, parent B. Yes, this is the cutting point. I will say this part, okay, from the parent 1, and this part will go in. This part will be parent 1. So I will combine crossover means cross. Not I can also do like this, but no. This is the crossover like this. So you can see I have here the scatter plot has come here, and the remaining part, this part, got joined with this part. You see, it comes here. So the first line X by C, and then pie chart. This one comes. Then this. You see how it came. And the second part, what I can say, bar chart. This crossover. This is coming here. You see. So this part over here, the first line will be here. Come. So finally, you get the 2 offspring from the 2 parents. Okay, offspring 1, offspring 2. Yes.
In the algorithm, why you will pick 4 elements at the beginning if you only choose 2 afterwards?
Because to cover the more, we have the 50. You see, if I can cover out of 50, I need 2. The sample space is reduced. You see.
What's the purpose of choosing 4 at the beginning instead of 2?
That I am saying. If I have 5 people. And just suppose, let's say like this, I have 10 people. Okay, let's suppose in this class, the real example, I have to find the best student. Okay, you will ask me, you can choose any 2. Okay, I choose you and him. There might be a possibility there is other two more. Okay, if I get a chance to choose the four people, there is a high possibility I can find a good person.
But you choose randomly between the pairs, the first pairs.
The first person is binary tournament.
Okay. Okay. So between A and B, you
Yes.
choose the best one.
Yes.
Okay.
I am choosing the four people randomly. When the four people come here, I will take the test. You see? And you are saying me just choose the two, that's your question.
But so what's the difference between binary tournaments and offspring?
Okay. Binary tournament is based on the fitness value.
Okay.
Okay, that I will teach you later. There is a one value on the basis I'm deciding. And the second is the offspring. Like, see, you are intelligent. This is your feature. And you are the human being. You see, there is difference between the human being and your feature. You are intelligent. Same like, offspring is like an individual, like human being. And fitness value is his characteristics. Can be intelligent, can be weak, whatever. You see the difference? So we are generating a human being, and this human being will also have a characteristics. Like we are generating a dashboard, and this dashboard will have a fitness value. And then we will see the generative dashboard have a good fitness value or bad fitness value. Then we are comparing this value, the final, with the initial people. So you see? Just for you for better understand, just suppose there are two people in this room, okay? You have very good skills of development, okay? And he has very good skill of the design. If I ask you to develop a tool alone, you cannot develop a good. If I ask him, he cannot. But I mix both of them, you see, you will develop a very good tool. This is what I am doing here. I'm mixing the best thing of the both. That is the GA. So here I hope it is clear how we are generating the two offspring here. Okay, and the offspring we are making a crossover very simple. We are taking a good features of each dashboard and generate a two new dashboards. Okay, after having a two, now I don't know which one I can make here the fitness value, but I am for the moment I am just taking the random to let the GA work randomly. Okay. Now after just suppose I have taken the offspring one, you can see here. Okay, now I have a dashboard one. I already told you I can do a mutation by three ways. The first way of doing the mutation is DA-VA mapping. That's why I teach you in the first module what is data attribute and visual attribute. Okay, so these are the data attribute. Okay, and I give you the task initially. You can choose any. I give you the task of the pie chart. You can choose the data attribute. Okay, so here just suppose this is X and X is I can say numeric. So what I will do, I will try to find other numeric value in a data set. Over here there are only 4, but when you see in the student data set, you have around 10 numeric values. I don't know 4 numeric values. My question is here, if X is mapped with the A1 and you have an attribute A1 to A17 and from A1 to A10 are numeric and A11 to A13 are ordinal and A13 to A17 are nominal. It's clear, I hope. We have a data set of the 17 attribute, A1 to 10 are numeric, 11 and 13, 11, 12 and 13, 3 are the ordinal, and 13, 14, 15, 16, 17 are the nominal. See? So X have a numeric is mapped with the A1. Okay? I can map it with the A10 also. Do you agree, guys? I have other options to map it. Okay? So I can map from X A1 to A2, A3 in this case, A10. Because both there is possibility. So this is known as the mutation. Okay? Same I am doing here. So this is known as the mapping mutation as a mapping between DA and VA. Okay, little bit complex. Okay, maybe I can see your faces. I don't know. You understand it? If not, I can try once more. Okay, let's see the data set. So my point is like this. We are building, let's say, bar chart. Okay. We are building a bar chart now. You can see over here. We are building a bar chart. On the x-axis, we need someone as a categorical, ordinal, nominal. And we have here now how many attributes? How many ordinal, nominal you can see here? The categorical. One, so we have only one option. Okay, but in the same way, if I am building a scatter plot, okay, on the x and y-axis, on the x-axis for a scatter plot, what I need? Here, numeric. And by also I need the numeric. So what I can put here? How many numeric you can see? 4. Can I put the A1? A2 also? A3? Anyone? A2, 4. This is what I am trying to say. Here, A1 to A17 are the total attribute. A1 to A10 is the, I am considering a data set the student, okay, which have the 17 data attribute. So I am trying to say here we can make a mapping. If X have A1, I can do X with the A2. So this is the point I was trying to say here. This is the X, okay. If X means X-axis, okay. You are saying X as the A1 and you already say I can do the X with the A2, A3 and A4 also. So this change is known as the mutation. What is the maximum possibility of this mapping? Same you can do for the by, okay. But if X have taken the A2, then the remaining option in the ICE data set is the A1, A3, A4. You cannot take the A2 because it is already there. If you take the same at the same both the axes, it's quite difficult, not a good visualization. You see, such kind of the mapping between data attribute and visual attribute is known as the mapping as a mutation. If you understand this part, then both are very simple. Okay, we got a of string 1 just to show you, which looks like this. Okay, SPBHB, I just so remember. Okay, SPBHB. Okay, on the next slide, I have removed at the bottom. Okay, histogram I removed from that part. So we need be remaining only 4. This is also mutation. Just suppose I remove someone hand out. I change the human being. You see here, this is I am removing. So I am adding here, and here I remove it. Between the scatter plot and bar chart was the pie chart. Now there is no pie chart. I do the mutation. If I add someone one more hand, he will get the 3 hand in the same way like here. I have added, and here I have removed. So these are the different ways of doing, I can say, mutation. 3 ways. Okay. So now we can move forward. And the replacement I already explained. If these values are quite good, we will compare the value. Okay, initial and last, and finally we will have over here. So here the dashboard 2, which added visualization, and finally I can see here and here. The fitness value is coming like this: match, score, coverage, complexity, and match score is basically how many attributes you have matched, which is coming from, I can say, I have told you the McKinley matrix. Okay. From that McKinley matrix, I am taking some values like 150, okay, and on the basis of that, I am getting over here. I will not go much detail, a little complex. And coverage means how many attributes, if in a data set I have 17 attributes, okay, how many attributes are covered in this dashboard, okay, like on the here the genders A1, 2, 3, whatever the dashboard, I will count them, that this dashboard covered around 10 data attribute out of 17. So this is the coverage, and complexity I have given you the task. Remember, in the first module, I had the complexity. Okay. So on the basis of that, we have made our fitness function. We will see. So these are data set just to show you. So this is the dashboard evaluation function. Okay. So dashboard evaluation function is basically we are using here a function. So fitness function is basically where I can see like this. FD is a fitness function, which I already seen how I'm comparing a feature. Complexity, you know well, how easier is to understand a visualization. If visualization is very difficult to understand, it means it's very complex. The histogram is very simple. So I give you the complexity is very less. Like scatter plot offset is very difficult to understand. It means I give the high value of the complexity. You see? So if you understand complexity, it means you understand one third part of this equation. If you understand the coverage importance, means which data attribute was covered. It is very simple, like I covered in my dashboard 10, 5, 17 whole. It means the coverage importance, and each data attribute we have assigned the value, and that value will be assigned by the user. Just suppose as a gender, I will say I like this particular attribute. This attribute must be in my dashboard, and you give the value 100. It means it's very important for you. You see? So this is how we are taking that. And match score, I will not go in much detail because it's a little bit complex and it will take me 15-20 minutes to explain. But for you, you can understand. I have shown you the Mackendale matrix. From there, I am taking a value. Okay, after then, just to let you know, remind. So this table and this table, with the help of this table, we are taking that value of the match score, how it is matching here, the position, you see, here also position and here also position. Okay, so the mapping between these two tables is actually the coming from the that value. So coming back to here, so this is how we now, this is the fitness negative of the complexity, because we want to minimize the complexity. Positive of the coverage and match. It's also positive, it's also positive. Now there is a question, why we put this equation like this, minus, plus, into. We also put the plus, we also put the division, but the final testing, the value which we want to get is like after making an equation like this. The expected desired value. Okay. We got, then we finalize this equation. We tried many different ways. Okay. And this is how the graph runs. The best value, the worst value, and the average value. Okay. So the fitness function is the fast to compute, and there are 14 state fitness evaluations for each dashboard. Means the dashboard I show you calculation of the fitness value of one dashboard. So you can see 14,000 dashboard fitness value was evaluated per second. You can see the speed. That's why I ask you the what is the meaning of the complexity of the algorithm. So here is the meaning of the complexity. Or you can say 20,000 generations. Okay, that here is 14,000, 20,000 generations with a 50 dashboard as a population was done in just 6.4 seconds. So we did everything, and this is the mostly part of my second day of the PhD. So this is the data set. Now if you understand everything, so I will quickly tell them. So this is the student data set where we make a different scenario 1. Here the gender have a value 100, you see, user importance. But here the user importance is 50. So just I tested, if I am changing this value, how my visualization are changing. You see, scenario 1, scenario 2, scenario 3, okay, the 100, 100, 100, 100. then 50 and 10. Scenario 3 of the dashboard is like this. Like this. And scenario 4 have the something like this. So the main difference how it is changing is our user importance. Nothing is changing. The first, second and third, all three are same, but you have to focus on the user importance. It means somewhere our tool is focusing on the users. If you change your value for the data attributes, your dashboard will also change, and that will be get reflected. So the slide I have explained this over here, and I told you why we have chosen this equation. So answer is yes. We already tried many other equations, but finally the expected result come in that particular equations. But we don't stop over there. We consider a dashboard, but one more point just to tell you over there. You can see here the 50 dashboard with 20 generations. Now I will point out this in that table. When you see the dashboard are 10, as a population when I have explained over there as GA, okay, 10 and the generation are 1K, the fitness value is 0.6. And our agenda is getting from the minimum here 0 to maximum the 1. You see, which is the objective of any heuristic algorithm, to get the maximum value. Then we try 1K as a generation, and with the dashboard population 10, 20, 30, 50, even we tried the 100. Okay. On the vertically, when you see 2K, 2000, 5000, 10,000, 20,000. And on horizontal side, you can see the dashboard in a population. When you find over here this value, we got the maximum. So we don't choose 20K and 50 randomly, just we want. No. We make an evaluation and testing after running, and we prepare such kind of a table. This is the only one table I show you, but we do all 4 scenarios like I show you here. We do the same thing for all 4 scenarios. You see? And this is how we make a decision up to here. So now I'll give you a more detail about the dashboard generated. So the question that you have asked, why we are using the GA, okay, we will see here. Why before we can also get the random generation, some dashboard in a random generation, like 50. We can choose the best from there. There is no need to run a GA. What you will see, without running a GA, the dashboard generated from the initial population, the 50 that we have generated. See here the value is the total DA covered are 11, and primary attribute 5, secondary 1, and low DA are 2. Just to remind you this, how we got these values, you can see here. Yellow, green, DA means the primary, and then less value, secondary, others, and no value. Okay, so this is how we the total DA, primary means 100, secondary means 50, and low means less than 50, or like 10 or something like this. The value we compare of this whole dashboard, I already told you about the match, coverage, complexity, fitness. The coverage means which comes from the McKinley matrix, okay, and which mapping. Coverage means how many data attributes got covered. So total attributes got covered are 9 here. The value mathematically we find is this one. Complexity means the visualization is present over here. Like we consider scatter plot is complex during this algorithm. Then less than scatter plot, we consider the pie chart. Less than pie chart, we consider the bar chart offset, then bar chart, then histogram. Means the simplest chart for us when we develop this algorithm is histogram. Complex is the scatter plot offset. Offset means which have this something like here, not simple. Okay. So this is the initial. Now you will see the other dashboard when we get the G after GA. Now you can see here. The match value is 0.9, but the important over here is the complexity that we will see in the next slide. You can see the first thing, simpler visualization according to us. If you want according to you, we can change the value. It's simple. The task one was given to you. Okay, so it is like I can say customizable. Second, match score means number of attributes. You see, there was 9, here is 11. Means somewhere GA is giving you better result. Okay. Primary attribute are 6, secondary are 3, and lower are 2. So you can see the dashboard how it is changing. Now we will compare both of them.
Just a little bit, please. So the question was what? Why we choose genetic algorithm? Tu avais posé des questions sur pourquoi on va choisir un algorithme génétique.
My question is, it was about the algorithm.
Good.
It was another question about the algorithm. Yeah.
Why the algorithm or about the algorithm?
No,
There
it
are-
was about
About, okay. Bon, le principe des algogénétiques, je pense que vous ne connaissez pas forcément, c'est ça? Bon, je pense qu'il a expliqué tout à l'heure un peu. Can you go back this a little bit? More with the genetic different operators.
This one or this one?
This one. L'objectif d'un algogénétique, c'est quel que soit le problème, c'est de faire l'optimisation. On pourrait prendre des réduits simulés, on peut faire du grid search, on peut faire d'autres choses, mais c'est un objectif d'optimisation. Le grid search, la problématique, c'est qu'il va explorer tous les espaces de recherche. Explorer tous les espaces de recherche, c'est un problème NP complet, c'est pas réalisable. Donc, l'objectif des algorithmes génétiques, c'est de réduire l'espace de recherche. To reduce the space search. Pour pouvoir réduire l'espace de recherche, il prend le principe d'avoir une représentation génétique et d'avoir les principales opérations génétiques test. La mutation, on prend une valeur pour une autre. Le crossover, le croisement de gènes entre eux ou de chromosomes entre eux si on souhaite, pour pouvoir faire des variations. Et, donc ça c'est la mutation, le crossover. Et ensuite, il y a globalement ces mutations-là, elles sont faites en essayant d'optimiser une fonction. Alors, dans la vraie vie, c'est quoi? C'est la fonction de survie. C'est notre survie, des petites espèces, c'est comme ça que ça fonctionne. Donc, la reproduction, et ainsi de suite, ça fait partie de ça. Et en informatique, bien, ça va être déterminé par une fonction. Fonction d'optimisation, la fonction qu'on souhaite optimiser. En apprentissage, vous souhaitez optimiser une fonction. En fait, le learning, vous avez une fonction de loss à réduire. C'est un peu le même principe, sauf que cette fonction-là, elle est faite de manière itérative. Elle n'est pas faite par apprentissage, elle est faite de manière itérative, avec un certain nombre d'espaces dans lesquels on va essayer de réduire, en essayant de guider les solutions vers l'espace de recherche le plus comment dire, le sous-espace de la recherche qui est le plus, qui semble le plus bénéfique, dans lequel on suppose qu'il va avoir l'endroit qui va être le plus pertinent pour pouvoir faire l'espace de recherche. C'est un principe heuristique. C'est une heuristique. Alors, can you go back after?
Yes.
Not back, yeah. Not the other one with the operator. The other one again.
Next one?
Yeah. Yeah. Donc là, le crossover, c'est très simple. C'est l'idée, on va prendre deux individus qu'on veut croiser. On prend un endroit où on veut faire la séparation. On détermine le même endroit dans les deux côtés, donc il faut que ça soit par rapport au nombre minimum. Et on prend d'un côté, on lui ajoute la queue de l'autre. Donc on a croisé, ça s'appelle le crossover. Alors ça, c'est du crossover avec un point de cut. En génétique classique, on a plutôt 2 points de cut. Les gènes font à peu près la même taille, donc on a 2 points de cut pour pouvoir faire les crossovers. Quand on a un point de coupe, bah, on fait juste ça, et ça permet d'avoir 2 nouveaux individus qui sont issus du croisement des autres. On essaie toujours d'aller plus précisément sur l'espace de recherche. Et après le crossover, ben, on a donc 2 individus et maintenant il va falloir quand même sélectionner finalement le plus pertinent. Le plus pertinent, il va être sélectionné par rapport à quoi? Qu'est-ce qu'on cherche à optimiser? J'ai parlé tout à l'heure. Une fonction, effectivement, la fonction optimisée. Can you go after this? La mutation, c'est la même chose. On va juste transformer. On va dire qu'on va sélectionner une colonne de manière aléatoire et on va transformer la colonne par rapport à ça. Alors, il y a des algorithmes pour essayer d'optimiser la manière dont on fait l'aléa, mais ça, c'est une autre problématique. Go after this. Donc là, on a ajouté le rythme de pouvoir enlever une visualisation et de pouvoir en ajouter une. Ça, c'est des choses qu'on a fait dans la mutation. Et après, on a une population de départ. On a une population qui a été générée. Et on va essayer de trouver les individus qui sont les plus performants. Donc, par rapport à la fonction de coût, on va enlever les individus les moins performants. C'est à peu près le principe. Ça va, c'est compris là, au niveau des idées? We can go again in English.
No, sorry.
So can you go after, please? After. Okay. Stop. Et donc, nous, la fonction de coût, c'est ce qui va être important. C'est la fonction à optimiser. Et ici, cette fonction à optimiser, elle travaille sur deux aspects. We have two main criteria. The complexity. Il faut que l'algorithme, que le dashboard soit le plus facile à comprendre possible. Et ensuite, on a ce qui va être une combinaison de la couverture, c'est-à-dire à quel point on a couvert les nombres d'attributs, et à quel point on répond, les attributs couverts répondent aux préférences de l'utilisateur. Ça, c'est le matching. Donc, on fait une combinaison des deux, et on enlève la complexité, parce qu'on a pu faire un an la complexité, ça redonnait un peu le domaine pour faire la simplicité, et c'est le même principe. Donc, on fait une combinaison des deux, avec un opérateur ici, qui signifie le « et », sémantique, et ici, qui signifie le « ou », sémantique. Et donc, on essaie de travailler là-dessus, pour pouvoir travailler, pour pouvoir avoir une combinaison sémantiquement qui permet d'avoir. On a effectivement, comme il a dit, on a testé d'autres fonctions qui combinent les trois. Celle qui nous a donné, en tout cas visuellement, les dashboards qui nous paraissent les plus pertinents pour l'instant. Il y a aussi des analyses visuelles qui ont été faites. Go after, please. Donc ces scénarios-là, ils correspondent à des volontés aussi des utilisateurs. Donc là, on a gardé les mêmes choses, on a juste changé les préférences des utilisateurs parce que c'est finalement ce qu'on a utilisé de manière la plus facile des utilisateurs dans les autres en disant celui-là, je le besoin, celui-là, m'en fous un peu. Moi, ce que je veux voir, c'est vraiment ce qui est là-dedans. Et comment ça se compare par rapport aux autres. Et c'est grave, sur ce scénario-là, il a mis clairement en évidence trois attributs, ces attributs-là en vert et les attributs en jaune de manière un peu moins importante que les autres. S'ils y sont, tant mieux, s'ils ne le sont pas, ça ne devrait pas être dramatique. Et si on fait une génération aléatoire, ben, ça c'est ce qu'on fait en première, on va avoir des performances, mais qui vont être plutôt réduites parce qu'il n'y a pas de guidage sur la manière de prendre un dashboard qui soit plus pertinent. La génération, elle se fait par rapport à un ensemble, dans lequel on a un ensemble de visualisations possibles, dans lequel on affecte les possibles attributs. Donc là, il vous a expliqué pourquoi il avait choisi 20 000 runs et 56 générations. Next. Encore. Donc ça, la première, c'est une génération aléatoire. Before. Yes. That's a fully random generation. Is it that?
No, before initial population.
The initial population,
Yeah.
that's fully random
Ah,
generation.
okay, random generation. Okay.
You're right. Donc, la population initiale a été générée de manière complètement aléatoire.
Oui.
C'est un exemple.
Yes.
Then, the dashboard generated by the system developed by Dragon. So, comme on peut le voir ici, on a des dashboards qui sont sémantiquement un peu plus faciles à comprendre. Visuellement, c'est plus facile. Est-ce que vous pensez que ça c'est facile à interpréter? Alors, pour un expert, ça va être principe. Ça va être très intéressant parce qu'on va pouvoir voir de manière précise des certains phénomènes. Pour un non-expert, il n'y a pas de plus-value, on est d'accord. Pourtant, ça, c'est ce que génère la plupart des outils de dashboard à l'heure actuelle. Parce qu'ils se dessinent aux experts. Pas forcément d'utilisateurs de liste. Next. Ce genre de graphique-là vont avoir des significations un peu plus importantes. Voilà, de une simplicité un peu plus importante à comprendre. Bien que celui-là, is more complex because they have a lot of values and a lot of colors, so it's more difficult to differentiate the different colors. And that's the limit of this kind of graph. We have also the possibility to have some complex graph, but less complex than the random generation. C'est bon pour tout le monde? Vous avez suivi tout le monde? Ok. Thank you. I will let you. Bon week-end à tous.
Okay, thank you.
Enjoy your weekend.
So, I hope things are more clear in French. So, So I was here to just give you brief. So we have compared. Okay. So you can see there is a dashboard from initial population on the left and dashboard on the after GA. You can see on the right. So you can compare. On the match score, it's almost same. But in the coverage, you will see after GA value is high, and complexity after GA the value is low. You see? And the fitness value is high for after GA. And initially it was 0.099. So you see the difference, how much it changed. Okay. And on the other hand, when I will see data attribute, total data attribute covered from out of 17 was 11 after GA, and before it was 9. Primary was 6, before it was 5, and at the last secondary was 3, increased by 2, and it was 1 earlier, and low are same. So you see the difference how GA is helping us. So I think here the task C, so you can use your data set, okay, and try to generate a dashboard, okay. You can choose the visualization what you want, and try to cover all the what I can say data attribute, okay, like student data set of the 17 data attribute. You can generate a dashboard having maximum 6 visualization, okay, which covered all the data attributes. And for your help, you can use DA type like nominal. So I think it's very simple. You can choose that. Just suppose that I can say you don't focus on the complexity. Just you can say choose the scatter plot. On the x-axis, you can find any attribute. On the y, any numeric, and then here you can give the offset. So one scatter plot will cover how many? 3 attributes, data attribute. So you can try this. And you can generate any one dashboard. Data set you already have in Teams, and a little bit information will be here. If you are able to do this, I can say you've covered my first year of the PhD. Okay. Just try and let's see what will happen. Try to make one scatter plot and one pie chart, okay, and one histogram. Can anyone try, or if you anyone can try over here? If anyone is interested. Anyone want to come over here and try? No. So should I wait or move forward? I can come here.
Just 5 minutes. I use just 1 or 2 minutes.
So just to help you, you can choose an scatter plot. Okay, I can say, let's say A1 over here, A2 here, and A3 here. Okay, I can say SP. Then I will say I can try one histogram. Okay, where I can say A4 can come here. That can be numeric again. So I will say histogram, and then I will try some pie chart. Okay, which can also cover one visual attribute. So I can say A5, but you see I covered only 5. You see it's not easy. Then I will try one more scatter plot, like where I can say A6, A7, A8. Okay. Now I can again scatter plot the pie chart. I can try one bar chart offset on the here. I will say A9. Okay, and bar chart offset. Okay, so here will be also one like, so that will be A10. You see, I have taken the 5 visualizations, but I only covered the 10. Okay. So what I can do is I can try 6-1. So the thing is that it is not possible to cover all the attributes with the 6. You see? So you have to go beyond. That I want to understand from you guys. That's why it's only 6. So try how many visualization can cover. So now there is one hint. It is not possible with the 6. Maybe 7, 8, 9. And everyone answer can be changed. You see, we are doing it randomly. I hope you understand. So those who have completed, you can let me know. Okay, I am continuing forward to save the time. So we cover the 3 modules. Now I come with the.
If we use 6 visualization with 2 dimensions and 1 offset, we can cover 3 attributes per visualization.
Yes.
So
18. But the problem is that that you have didn't see, like I will show you. You mean scatter plot can cover the 3? So I will write here. SP cover the 3, and you mean the bar chart offset cover the 2, right?
And if we use 6
I got your point. Just so it's so, but you know, scatter plot will use the 2. Yes, 2 numeric and 1 ordinal. Okay, and there are maximum 4 numeric. If you read the data set, because I remember the data set. You see? So 1, 2, 3, there are only 4 numeric. And the scatter plot need 2 numeric. You see? So only you can make up 2 scatter plot. 1 scatter plot, A1, A2, okay? A3, A4. You see? A1, A2. Then you can say SP, A3, A4. Now we will try the 4th one. Now here you will get the numeric value. No nominal, 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 ordinal, 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 ordinal. You see? This is the main game. But I like you, check. I was expecting such kind of a question. I see, thank you. Okay, any other questions? So those who tried this question, please let me know once you finish. I really appreciate because this is not easy part to do. I personally know. Even when I was preparing this slide, my supervisor told me it will be a little bit task, which will be difficult. So now we will jump to the system design, development, and user evaluation and dashboard analysis, which is the most important part when I ask the question, do you guys know some tools like you say I know Power BI and something like this. So you know this part well, okay? And even I hope you don't know, anyone know how Power BI got developed. I'm not saying how you know how to use the Power BI. This is a different question. My question is how Power BI get developed. So anyone know how Power BI got developed? The behind scene of the Power BI. This is the main thing. So we will see here in this module 4 how we develop any particular tool and how I have used my module 2 and 3 to develop the module 4. Okay. So this is whole system, how my system work here. So basically first is the data pre-processing, and after this module I will show my tool how much I have developed till now. Okay, so it will be interesting for you guys. So data pre-processing means you already have a data set, like I send you student as or adult. Then you uploaded the data and we have the different model, data model, task model, user model. Okay. These model means we are dividing the different ways. When I say data model, I am getting the metadata. Okay, metadata contains the four things, which I show you again. I will show. This 1, 2, 3, 4. These 4 things are known as the metadata for me in my case. First, data name I find from this particular data set. Data attribute type I already told you. And unique values, it means number of unique values present in whole data set, not whole that particular column. Like the column name is the gender. Like gender can be male or female. Okay. So unique values can be how many unique values are there? Tell me guys. In a data, you have a data set. Okay. In data set, let's say a column with the name gender. Okay. In a gender column, whole column, there are around 500 values. How many unique values are there? Unique, which is not repeated. 2. Yes, this is what I am doing. For every particular, what I can say, data set or data attribute, I am counting the unique values. Okay. That is known as the statistical properties of a data set. When you are evaluating a data set on a mathematics. Okay. Then here I can see user importance. With this importance is will be assigned by the user or randomly my tool will take. Okay. Now coming back, we will use it later. So data model is the metadata we have collected. Task model, what you want to do, like what kind of the user, you are novices, you are beginner, or you are expert, that I told you. Okay. On the basis of that, we will see your task like analysis, just to view. Then user model, again I can say here I will say what kind of the user you are. Here the different the task, what you want to do, basic analysis or advanced or insights, and there's the type of the user. Visualization model, I told you when there was a table, okay, McKinley matrix and one table visualizations, how the mapping was done. That's the visualization model. Here, when all this come together and user feedback, if user want to do, the user importance, okay, will give you the whole dashboard. If you don't want to give anything, still the dashboard will generate it. But if you want to make customized, you can do this one. How I plan this whole tool, when I think, I use detailed planning on documentation, then selection of the tools like for UI design, Miro, Figma, PowerPoint also, okay. Then I can say development, selection of the stack, and testing user evaluation. So you can say design, like Driver is very good for the design experience, and icons, I use the schematic UI and flat icons, okay. I will not open them, but just to give you an idea. When I start doing this design, you can see my first design, how it looks like. Hopefully very well. You see? Then the second, how I improve. The second screen, the first screen, then second screen, and then the third screen is improved like this. So then my tool there are 3 screens. This was this one idea. This first screen was like this, second, okay, and then we improve like this, okay. Still the final version not yet. I will show you. Now there is a selection of the stack. If I want to develop a mobile application, I generally go with Flutter because it gives you the mobile in both iOS and Android. Nest.js, a framework which was developed on a React, and React was owned by the Facebook. Node.js is again good for live users, real-time data, and MongoDB for the data set. But in our case, I am not using Mongo because we are using only Excel. Okay, so I am using Nest.js and Node.js. So anyone who have used anything of them before? MongoDB. Who have used the Node.js and Nest.js? Nest? Both of you? Anyone have used Nest.js and Node.js, which are more interesting? For the backend Node and for the front end Nest. So here the UI, what is current version we have. This is the automatic dashboard generation, recommendation system. In 3 steps, you can get your dashboard, upload the file, configure, and then visualize your data with the automatic generation system. When you upload your data, you will get a screen something like this, where your metadata, you see here, you can edit it. Okay, user data, the data what you uploaded is here. You can see. On the basis of this data, you can also change this value if you want. Okay, and user importance is under your control. Which data do you want? Here is some user preference. You want a complete automatic. Okay, it will be checked. What kind of the user you are? Novice, beginner, or whatever. Number of visualization you want to see in your dashboard like 0 to 9, but there should be a 2. We have changed it 2 to 9. And selected visualization. Which visualization do you want to prefer? In select. Even if you don't want to select, you can select this, it will automatically selected. Okay, that's why I have given you the task 1 to see the complexity, how you guys think. If I will get some feedback, I will make change over here. Because ultimately I am building for human beings. So feedback is very important, otherwise everything is spoiled. When I will click over there the next button, then we will get this one. This is the final visualization. The parameter setting over here, select visualization, number of visualization you can see here 2, GA parameters, mutation and crossover. This is not for the common people, only expert or the beginners. Some button like layout and these, or I can say the complexity icons. These icons can be hide also. GA, full screen, download. You can take the notes. And here are the review, personalized dashboard also. Feedback, tutorial, help, all this related. So this is the final screen what we have. The screen was divided into three parts. One is setting the GA parameter on the left. In the center, dashboard with the button navigations to inject with and analyze your data. And then dashboard selection and feedback. Okay, do like here. We have a different cases of the feedback, like very bad. When you will give, you will have something like this, very bad and bad. On the basis of your feedback over here, we will improve our system again. Okay, where the problem you're facing. Good, you will get something like pop-up. When you select, you will get answer. Very good, something like this. But excellent, then we will give you some thank you for using this our application, and then we will ask you the overall system feedback. What you like in this, what you don't like, how we can improve. So again, the feedback is very important. So as I told you, the general feedback, the point number 5, the excellent. We will have after general feedback where if you will say yes, yeah, I want to give a feedback for whole tool from screen 1 to screen 3, then you will have question something like this. Do you like the tool? The spelling is not correct. However, and then screen 1, screen 2, the visualization are easy to understand. You can rate 1 to 5. Do 5 icons present on each visualizations like this. Wait. These 5 icons. Okay, and do GA is helpful, do user feedback integration gives improved results, GA parameter, tutorial, all this. So this is how we build a tool. Now we will also perform a user evaluation that I already told you. To make the high possibility, we will choose some student from in lab from below or Lil. The reason behind I am choosing student from there because I have my supervisor one you already saw. See, he is from below and one from the Lil also. And one from 2 also, but we don't know because we want to do evaluation with master's student, especially with the BDMA. Create a group of students, then some setup in a lab. Student will use our tool and with some given data set, what they don't know already. And screen will be recorded if possible. Think aloud. You know the think aloud protocol? Anyone who know about this? Think aloud protocol. Yes.
Everything
Hmm?
is that you said everything you think when you use the application?
Yes, you mean when you are using the tool, you have to speak. What you are thinking in your mind, you have to speak. Oh, it's good. I don't want this, so that we can record your voice, and then we will understand the psychology of the person, how he think while using our tool. This is known as think aloud. And finally, we will interview the people after using our tool. What you like, what you don't like, why you don't like, why you like this, how we can improve. And we can also perform a comparative study that I already told you. How to, we will just suppose when I have read the 19 tools, I told you, I have select 1 or 2 from them. And we will ask student first use this and then use this, which are most similar to our tool. So we also use this data set. You can see the IRIS data set and census data set, and we got very good results over here. The good graph, which can easier to understand and interpret and make decisions. So now this module is finished over here, and before we begin the next module, I will give you a short demo of the, I can say, tool what we have developed. So little bit I will do a coding part to show you. Yes. Where? Thank you. Okay, sure, definitely, no problem. So I end the code simply. Now I will go in the local host and I will try to run. So I hope you are able to see the first page of the dashboard where you can see the features, and when you click here, you will see the features, you will see the publications, you will see authors. Okay. And then we can upload a data, or instead of uploading a data, we can also select a data here, like student. Okay. After selecting a data, you can see here, you can get, this is the live tool what we are showing. Like data attribute, like gender and everything you can see here. When I go here in the left, all tools, you can change a value like this. Okay. So now you can change a value, like here it's the one, I can change 25. Okay. Here is like I can exclude. So here we can change the values. Okay, 100, whatever, user importance. If you don't like, you can also change it nominal, ordinal, or numeric, what you feel. And here you can also see your data, what is actually. Now when I click on, before I click, I can also select here no biases, beginner, advanced. Okay, if you see, I will see the beginner, this will select it. If I select, yes.
If you select all of them, you get more diagrams, plots.
Yes.
Okay.
It means if you select any one of them, it means you want to see this visualization in your dashboard. Okay. And according to our understanding, we consider, when you will see here no biases. Okay. You see here changes, only 3. When you select is advanced, you will see all are selected.
Okay, but for the results.
But then here you mean like this? Yeah, this is also working. This is your question, I think, right? So we can, this is the whole customization. If you want to know, then it will not work. So I will select beginner. Oh, let's show you with the no biases, then we will go. Okay. Now we will generate the tool. So your data is being loaded, and please wait, dashboard is being generated. So let me see. Okay. So this is the dashboard 1 which is got generated here. So you see here we select only 3. 1, 2, 3. Okay. And this dashboard 1 contain only 3 visualization. If I want, it should contain this or this. Okay. And if I change here the no biases, you see, when I change the user type from no biases to beginner and then advanced, okay, then you see the scatter plot is here. But when you click on the no beginner, it is not changed. The reason behind, we consider beginner know the line chart, but there is no line chart in the dashboard, so there is no change. And when you click on the top, you will see the match value, coverage importance, complexity, and fitness. These are the things for the advanced user, not for, I mean expert, not for novices. So let's go the big advanced. When I click on this button, you will see. I think I didn't implement, but otherwise when we click on this, all the visualization got ranked on the basis of complexity. Means histogram, and then bar chart, then pie chart, then scatter plot. It will work like this. Maybe I don't know it work. Yeah, it's working over here. So in complexity, you see the higher to lower. This is on layout. Basically, it will change horizontal and vertical. So we have to work on it. So one of the student, I think from you, I don't know, the name of the girl is the Daniela. Okay, she's working with me on this project on layout optimization. Okay, she is the master 2 student. I don't know, I think in INSA. Okay. So here are the icons. When I click on the icons, you can see on information, you can see the visualization. If you want to delete, you can delete it. Okay, maybe it's not working for the moment. When you zoom, it can be zoom out, zoom in. You can download it. Here you can see, okay, after download. You can also, when you click on it, you can create a personalized dashboard that we will see now after this. If you want to zoom it, you can see whole screen like this. Okay, you can go to, and if you want to download whole dashboard, you can download and see here. Okay, if you want to take a notes, you can also take. This one is important, something like this, what you want to say. Okay, so the center part is okay. On the left side, when you change anything over here, after that you have to click on this button, means here in the GA. As I told you, changing in the GA parameters and doing a mutation, something like this. Okay, give you a preference, like when you click here and you want to give value from 0 to 75, and then you can run the GA. Okay, and over here also you want that in my dashboard, I want the minimum number of visualization is like I can say 4 and maximum 7. Then you will get only that dashboard which contains 3 to 7 visualization. You will not get a dashboard with a 9 visualization. You see? So you can customize a dashboard. I have to work on setting, we didn't work yet. Tutorial still we have to work on, help, these things we have to work. And mutation, when you click, you can see like which one you want here. Add visualization, remove visualization, or mapping. Okay. And crossover, you can select, you can remove. Okay. So this is how every parameter is going to work for you. Now the last two features, just suppose I want to make my own dashboard and I like this visualization from here. I have added it here. I like this. I can also add this here. And from dashboard 2, I like this one. I can also add here. And I like this one. Oh. I add. Now I want to make a dashboard 2. I will lock it. And I will create a new one. This one. And then I will add this one also. Then I will go here and I will say I like histogram and I will add it here and I will lock it. If I want to create the third one, I can also create the third one. So you are seeing the features. So these are the personalized dashboard. These are the best dashboard we are getting from after GA. Now, if you want to give us the rating, not us, I mean that this dashboard which is in the center, you can click here that the dashboard is bad or good. When you click, you will get these visual options. The visualization very complex to understand. You can click. This is the problem. Some visualization are missing. You can select There are too many visualizations you can select. Expected data attribute are not found in dashboard. When you will submit over here, you will get the suggestions what you can do. Here the problem, here the solution problem. So do like this. These features again I will say not for the novices. I know they will not do. These are for the beginners, like students or experts. For novices, very simple. Just he upload the data in the screen number 2 and he will be here next. So now I think this part is done. So this was the demo of the tool. So if you have any questions, you can ask me, or if you want to see tool or whatever. So do you have any questions, or should I go further? Yes.
I have one question on how you compute your graph after on your code when you choose the plot you want. How you compute it on the Python or?
Okay, you mean the Node.js?
Okay, and it's not computing.
Yes, Node is computing. That's why I told you here. This one, I use the Node for the backend in Nest.js. That's all. And for the graphs, I use the Vega Lite. Vega Lite, you see. This one is the for graphs. So in Vega Lite, like what you have to do, just your bar chart. You can select this bar chart and just this is the code. Okay, you have to just take this code and where the X and Y, you have to take the value from my dashboard like here. This one. So X will come here, X you see, X by and offset. So I need only two values for this one. One is the X and one is the offset color, and by will be automatic calculated. You will see. Y is the value and type quantitative. Any other questions? No, so I think we left only 20 minutes and I will be a bit fast to cover these slides. So it's a kind of the basic understanding. I don't know if how many of you are interested to do research. So just let me know how many of you want to do the research after your masters, I mean a PhD or something like this, the research domain, or you will prefer to go in company to work. Okay, anyways, I don't know, but still I will let you know about all this part quickly. Okay, so when you are going in a research field, there is a way to especially finding a PhD. Okay, first there is CV shortlisting, then they assign you a assignment which will be research based. After that, they will give you some technical assignment. After having a technical assignment, you will have some interview with the supervisors. After supervisors, your final presentation to school jury, and then you will sign a contract, now PhD yours. Okay. And before that, you have to make an application with the CV and cover letter or the motivation letter. You can find some template over here. And how to apply? You can find many websites like UXS, Colliers, and some LinkedIn different ways to find PhD funding project. Second, analyze your understanding of the project, means subject domain. Okay, the domain you are interested. If you don't like, you should not go for that. Okay, you must have a basic understanding of subject, by surfing on internet. I hope you guys know this all well. Okay, but just to remind you, reading the literature once you are PhD, so it's very important to read your literature. And when you read your literature, you have to manage, because when you have a huge number of papers, like 100, 400, 500, very difficult to manage. First thing is how you can find a paper. There are different sources. Go on the Google Scholar, like I can go on the Google Scholar here, and I can find a paper like data sort. I can got here, or I can say, I can just type data visualization with dashboard. I can get a lot of results. Okay, this is how we can find a papers on Google. And then creating a drive where you can make some PPTs. I will show you quickly. So here I have some papers, just suppose this one, okay, and I want to read this paper. I read all this paper. After reading, I will prepare some outcomes, like you see this type, to understand well, and let me present my supervisor. Give you a detailed understanding of whole paper, okay, like this. And next we will have here the maintaining a database in Excel, that I will also show you, like when you go in a drive, you have Excel sheet, something like this. You can write a name, because I told you there are a lot of papers. So maintain an Excel sheet, name, keyword, category, priority, okay, online link, professor, college, commentary from your professor, whatever. Okay, so this is how you can do. Now when we go next is about, so next is about writing a paper. So to write a paper, you can go on Overleaf, you can find some template for writing a paper, and then use the I can say the Grammarly application to correct spelling and phrases on this. After that, you can have a flag check. Once you written your paper, the paper is good or not. And but for references, you have to mention them, okay? And better to use own images and graphs while writing the paper, okay? And if you use someone's, you have to give a credit. In selection of the paper, there are different types of the papers, like paper, survey paper, technical evaluation paper, overall representation of a tool, review papers, and others. And after here, you can make a publication of the paper. Your paper is final, now you have to publish it. So to publish the paper, you have different ways to find about journal ranking. I have given some link over here, like journal conference, okay. And when you go on SJI, you will find something like Q1, Q2, Q3. So the papers which are in Q1 and Q2 are quite good. Okay, and here also, like for conference ranking, there is a tool, or I can say website, where you can find like A1, A2, ranking of the conference, where you can find the conference which you are submitting a paper is good or not. So now you find your PhD, you written a survey paper or any paper, and you read it, and next is presenting a paper in conference. So basically, presenting a paper, you have to finding a good theme on different websites like PowerPoint or SlideGo, and then again make a presentation, and then practice that particular whole presentation with your friend or with your friends, or by recording it somewhere, okay, online tools. And some question, when you are making a slide, also make some slide for question answers after thanks, so it will help you, okay, to answer the questions of the jury, okay. And here is some samples and examples, okay. In my case, I will give you whole presentation, okay, so you can look into it, all these links, because we don't have much time to show it. There is some research ethics that you have to take care while studying or writing a paper, like all contributor name, those who contributed must be there, and someone really help you or guide you, discuss them passively, whether you are going to mention their name in paper or not. You mention someone else's name, don't forget to give the reference. If you are taking some content from some paper, give a reference of that. And all paper and patents are considered as intellectual property. So all IT law applies if you got any dispute. So you have to see the IT law of that country, like in France or Germany, whatever. Okay. Funding sources should also mention. It would be a good idea if you got funded. And minor help can be like someone have guided you like this. You can mention them in acknowledgement. And there is no stupid questions. You can ask what you want. So now final perspective on the BI before we end this lecture. So continuous increase in the data. So you can see why we need why this seminar is designed for you. There is a reason, because data is continuously increasing, and somewhere today estimated is 2.5 quintillion. So you can imagine data, how many zeros are there after 18, and the data is increasing every day. And when we go inside of the company, Google around have a request of 3.5 billion per day, and it stores 10 exabyte of data. You see how data is increasing. So need of tools for common people. So you can see the time saving. Okay, time saving, easier to understand the big data, fast analysis, easier to make decisions. In future, mobile will be also on demand. Small vendors can be used for common people, and many more can be added over here. And how company are dependent on this analysis of data using different tools. Okay, so if you know any tools, you will know about this. Business takes decisions on KPI extracted from the data analysis. They need BI tool experts, so means they need you to do this task. And there is a future jobs as a data engineer and data scientist and data analyst. So you can see the responsibility something like this, and common tools and other, how the business analysis is also known as analyst, scientist also known as the manager and statistician, and data engineer also known as the database administrator, data architecture. Okay, now maybe next slide you will be more attractive. So you can see the salaries are something like this. If you are working in US, maybe you will be here soon. Okay, so these salaries are expected. I have written if you are working in US, that's why not in Euro. So you are in dollar, because US is more demanding as a capitalist country. Okay. They pay you more and skills, but in the same time you must have these skills too, and these skills are not easy to attain and have expertise all of them. So now the question is what to do after masters. I don't know, many of you know well, but just I would like to present my comprehension of what I know. So first I will present the pros and cons. So the pros of both PhD and going in enterprise, because I am doing PhD, so how I know the worst benefit I am enjoying and what losses I am doing at the same time. So the gateway for academics, if you want to go in academics, deep dive into research work, and a good platform to test your deep research skills. Conference presentation and publication, we will go in conference and meet with the people. Student life still give you, you will still have a student life, so you have many benefits of the students, especially in France. Many entrepreneurial events, okay, you can be part, easily do what you want. There is no pressure, no boss for you, no manager. Flexible time management, you want to go, you go. If you don't want, you want to work from home, it's okay. Okay, if you're a good professor or I supervisor. Still option to jump into corporate whenever you want after PhD. So in business at the same time, you will work in team, but in PhD you don't have a team, you have to work alone. Okay. Salary is more compared to enterprise, compared to PhD, you will get a very good salary. Explore with others, you will work with others or other people. Freelance work, you can also do some freelance work when you're working at the same time because skills are almost same. Networking and after work meetings and great learning opportunities, okay, because you are meeting with others. At the same, we can see the bad side of the story for both master and PhD. Hard to manage everything alone because you are the designer, you are the developer, and you are everything you have to do. You are the writer, you are the presenter. So you see the first year, second and third year, but at the end of you are very good, you are expert at the end of the story. Literature review, which is very hardest part, I can say the boring part of the PhD, when you are finding the literature and you are reviewing, you are making a analysis, PPT, like what you learned from each paper. Very boring part, I will say. But once you do it, you will have a, I can say, the bank of the knowledge, or I can say ocean of the knowledge. You have very big knowledge of everything. Okay, like you see, I have seen the many tools, all the 19 tools are on my finger. I can read all of them and I know how to use all of the tools. So which is done in the last 2 years. And next, long way for writing, because you have to write a thesis at the end, which I'm going to do from, I think, March for next 6 months. Okay, so you have to write papers, journals, conference, and thesis. So it takes a lot of time to write. You used to writing. Quality is very important. If you want to do a PhD, you have to do everything with a quality because what you are doing will be your work. Okay, so no one is going to help you. Actually, your supervisor are there; they help you, guide you. Okay, but the work you have to do. When you are working in company, at the same time, your supervisor, your managers will help you to improve the quality of the work. Okay. So there is no team to leave, only supervisors. I already told you, and salary are quite less compared to, I can say, business or enterprise. Okay. Again, when we see the enterprise employee or a company, every day you have to go office until you have a contract and you work from home. Okay, work in a pressure, sometimes there are too much workload. You have to do many tasks at the same day. And hierarchical from top to down, you have a manager, then manager have the director and something like this. But in PhD, there is no hierarchy. You student and supervisor, that's all. Okay, so there is no miscommunication. And too many employees and too much competition in companies, and changes happen slowly. Means if you want to make any change in company, you have to go your higher authority, then you will go senior manager, and then director, and then the whole many, I can say, head of the company, then the change will take place. What in a PhD, what you want to change, you can do in your thesis. And staff and tight security, okay, I can say like this, staff and tight security. So I think we come over here. So I have few more questions over here. So you can open your book lab, and I think last 3 or 4 questions for you. And I will also open the book lab. Where is that? And so here is the first question. Okay. So I have shown you my tool. So these are the few questions. If you want, I can show it again, if you remember. So my first question, do you like the UI of the screen one? I mean, where we upload the data, the data upload. Okay, if you want, I can show you again. I don't know. So I am talking about this one. Do you like this? And I want your honest opinion. If you like, it's okay. If you don't like, no.
We have nothing on the.
Okay.
It's just we have nothing.
There are only 2 options, yes or no?
It's blank or blank.
Ah.
We can
I don't know.
Just, the first is,
Yes. Maybe I don't know. Now it's display. It's okay.
Yes.
Okay, I don't know. And if you have any comment or suggestion, you are most welcome. Okay, you can write me email and you can tell me, oh, this tool is not good here. So if anyone left, let me know. Otherwise, I can go next. So let's wait for 10 seconds more. Okay, so now I will go back. So now here the second question. Do you like the screen too?
what is the,
Question?
what is the since you?
Okay, I will show you. This one. So we have more answers. So now we can go next one. Those. So now you have third. Now maybe the question for screen 3 is something like this. When you generate the data and data come over here. So something like this. Anyone still left to give the answer? Okay, so we can go next. Okay, so here is the final question. So do you like a tool? Overall tool from everything what I show you? All the features and uploading a data, simplicity. Okay. I hope everyone is done. So they have these answers. Okay, so now I think there is no other question. We can go back to slide. So yes, these are the my supervisors who are helping me doing good research. From first year to now, the still students, you know, he was here. Okay, and Fatma Wali, I hope you don't know. She is the professor in Lille University, University of Lille. And Jill Bonchuni, and he's my director of the thesis and supervisor. He work in Tour. So I don't know if you know or not. But he's very expert in the same. I mean, all three are expert in all data visualization and all that. So I'm working under their supervision, and I have two students who are working with me. One is that girl, that Daniela Katoja. She's from Salwa. She's working with me on layout optimization. And one is the Ayush Balian. He's from India, on the university, and he's working on some part of the UI with me, and some automatic selection of the data attribute type, like nominal and something like this, to be selected automatic. And yes, so here we come at the end of the our presentation. So the last thing that I want from you guys, if you can give some feedback for me. Okay, so I will send you this feedback form. Okay. And it can be visual, I think, on Teams. So I put the feedback form. There is some questions like I can show you. So question something like basic details, just name, and quality of content that I present you, your rating and then comment, then delivery of the content. Okay, mode of communication clarity, then your comments again, ease of understanding the content, and then we have time of lecture. It should be not too long or something like this. Okay, you can see. Then level of given task and assignment, it should not be too hard, medium or something, I don't know, you can see. Overall rating of the lecture, how much time given task and assignment during the seminar and test you. Then test you given in the assignments, it was good or not, whatever you can see. And anything, you can say anything that likes or dislikes you during whole seminar, you can write here. Overall comment for the lectures, okay. And do you want the content of this what I can send on the email? You can, I will already get your email and I will send whole PPT or whatever I have, okay. So it will be very appreciated if you can give me this feedback, because this will someday help me to improve everything what I got from you for other seminars or lectures. As I always see, which are very important. Okay. So I think here we end.